Hi, my name is Ben. I'm part of a group of local government and NHS analysts who create a machine learning model to determine inequity in hospital admissions. This inequity is difficult to determine, as to calculate it, you will need to count the hospital visits that should have happened but did not. Unfortunately, we do not have these records. No one does. This project aimed to estimate these visits that should have happened and compare them to reality to quantify inequity in planned hospital admissions in our system. Our attempted solution was based on one huge assumption, that in the areas with low deprivation, access to hospital procedures would be perfect. Starting with this assumption, we trained a machine learning model exclusively on the lowest deprivation areas to predict planned hospital admissions based on an area's characteristics. The next key step was to leverage this model trained only on low deprivation areas to predict hospital admissions in high deprivation areas. The point of this model was not to actually predict hospital visits in high deprivation areas, but to see what the visits would be like if the area behaved as a low deprivation area. The point of this confusing daisy chain of machine learning was to be able to compare the true value of planned hospital admissions with how many there would have been under perfect access conditions. When this was run, it gave us simultaneously a prediction of the missing hospital admissions and the error in that predictions. During the project, we consulted with a clinical safety officer, Mark Ryan. We wanted to ensure that if a model was ever used, it would not unfairly discriminate based on any protected characteristic. We put in place plans to test how the model came to its conclusions based on age or ethnicity, as these were characteristics we had the most detailed data on. We tested primarily to ensure that when these were used, it had enough data to make fair decisions and the variables were not misused. As the model we created did not work on an individual level, but on a small area level, this was harder. But even so, we examined the feature importance and found no issues in our models. The primary reason for this was the data was either very nuanced, non-existent, or not used by the model. Planned outputs. In terms of what we planned to produce, our reach far exceeded our grasp. At the outset, we aimed for, it seems, every format under the sun, but time, technical limitations, and our own abilities conspired to severely limit what would eventually output. And the irony of this is it didn't matter too much, as you will soon find out. A key part of the project design was a way to create an estimation of the error on the final machine learning result. This was done by comparing a set of low deprivation areas that hadn't been used to train the model with what the model predicted. We assumed that the percentage error between the prediction and reality would transfer as well as the model itself. The distribution of percentage error was very large. It seemed to indicate that the model could vary wildly from the true value. On the screen currently is one of the core outputs of the project, a ranking of the disparity in access to operations. Higher is worse, and that means a greater gap between high and low deprivation areas. We plan to create rankings of ICBs, upper tier local authorities, and rank and compare them to England itself. See the horizontal line in green, which is the overall disparity in England. And at this point, it seems very rosy. It seems like an ambulance product we could use to make some policy decisions. But this is very misleading. There is something highly instructive missing from all the rank charts shown so far. Huge error bars, absolutely massive. Using the nature of the model pipeline, we're able to create confidence intervals for each prediction the model makes. As you can see, these are huge and absolutely wholly invalidate any ranking we should do, as the confidence intervals are so large that you could order any of the areas in any way possible. The upshot is the model we created could not be used. More refinement is needed, either a more complex model, but more likely more data. The intended impact of the project was to pinpoint areas that were needed to need support to get full access to planned admissions to hospital. The ideal model would predict the age, but we didn't get that far to model development. This overall would have allowed service planners in local government and the NHS to get a better estimation of where people might need better support in accessing planned hospital admissions. As you can see from the graphs on the screen, beautifully done by one of our team members in QGIS. So, reflections. Looking back on our time at the HSMA programme, we're glad we took the opportunity. The course gave us a wide view of the operational analysis techniques available and gave us the opportunity to pursue something that interested us. Although the project was enjoyable, there were a few stumbling blocks, primarily software and data. Getting the software for this project on every group member's machine was a challenge, and even up until the end, this hamstrung our efforts. But our greatest battle was earmarking time for the HSMA, especially the project work. Some of us really struggled with this as we were constantly drawn back naturally into our day-to-day work. Another issue was sharing data between organisations. Although data protection is a vital provision of the work we do, the lack of blanket agreements hurt this project's ability to explore the full possibilities that were on offer. We've not plumbed the depths of this problem. There may be a lot more to find. Just because we drew a blank doesn't mean it can't be done. But overall, all of us think this has been a great opportunity and heartily recommend it. So, finally, we can't give you a solid answer if planned hospital admissions can be predicted. But if it is, a lot more data is needed. We need to go deeper. Overall, what you will gain from this course and its usefulness will be determined by the support of your institution. Lukewarm support will mean you could have a tough time. And in terms of machine learning, access to data will make or break your project. If this could be an issue for you, avoid this type of project. And finally, never ever trust a machine learning model without a confidence interval. Thank you very much for listening.